Hi, everybody. Thanks for joining this webinar. I am Jimesh Shah. I'm a Senior Technical Product Manager at AWS. And today we are going to talk about encrypting and securing your business critical data with Amazon OpenSearch Service. So, what are some items that we would like to cover today? We will talk about identifying your data security needs and what are your organizational requirements. Then we will dive into what are the four pillars of security, and how should you think about securing your data. And then we're going to talk about how to take a multi-layer approach to security. Once we are past that, we will then dive deeper into the security core concepts within Amazon OpenSearch service. Um, Lastly, we will talk about the security best practices and what are some recommendations that could help you get started and get you into the right security posture. And then we'll give you some next steps there. All right, so let's get started. So as you all know, we will be talking about security with the Amazon OpenSearch service today. I'm sure many of you have tried the service today, or many of you are planning to try. But essentially, Amazon OpenSearch Service securely unlocks your real-time search, monitoring, and analysis of operational data. It's a managed service, so you can increase your operational excellence by using a popular open source OpenSearch software on our service. It's secure. We give you all the security controls to audit and protect your data. We also have observability features that will allow you to systematically detect any potential threats and react to those threats by scanning through all the data and logs that you're bringing into the cluster. We also have capabilities like alerting, anomaly detection, machine learning, and others. And the goal of Amazon OpenSearch Service is to keep your costs low and help you to scale your workloads. Yep. So before we jump into this presentation, I want to pause here for a moment and pose this question to you all. Is what are the data security needs of your organization, right? Um, we can give you all the tools. OpenSearch Service has many different security tools. AWS has many different features that help you with better security posture for your data. But what's the most important thing is what are the data security needs for your organization, right? So let's talk a little bit about that, is why you would need security for the data that you're bringing in to Amazon OpenSearch Service. Let's go over a few things here. Is, are you trying to protect confidential business data? Do you have like sensitive workloads where there's, PHI, PCI, or other confidential data that you're trying to protect? Are you looking for access controls on your data so you can pick and choose who has access to the right data sets and control that? Are you looking for an auditing use case where, as you are bringing in data to the cluster, as different users and teams are accessing this data, you want to make sure that you know you can audit all the user actions and who's sending what queries. And then we're going to talk about data encryption. So em- encrypting your data is very important, is business critical data. You want to make sure that no matter where your data lives, you want to encrypt that, whether it's on the disk, whether it's in transit and movement. You want to protect your data at all times. Do you want to build this yourself and have to worry about security patches, upgrading your systems, or are you looking for an alternative where the like Amazon OpenSearch Service can provide you the security patches for all our supported versions. We can provide you the updates, so you can have the peace of mind that your data is always protected. We also support integrating with third-party identity providers like a SAML identity provider. So if you already are using that, then you can easily integrate that with the Amazon OpenSearch Service. Or maybe you're looking for a system that allows you to um, meet the compliance requirements of your organizations. Maybe you need to comply with HIPAA or FedRAMP or many of these other compliance standards, and you'll see that Amazon OpenSearch Service complies with many of these industry standards. So essentially, you can increase the operational excellence by using an open source solution that is managed on Amazon OpenSearch Service. We want you guys to spend time on analyzing your data and not so much on trying to upskill and manage your deployments and adjusting configurations. We want you guys to leave that to us, and just so that you can focus on your analysis and generate the business insights that you're looking for. All right, now let's talk about the planning phase. Before you start looking at the different features that are available with the service, um, you want to think about what's the level of sensitivity of the data you have. That will help dictate what kind of security mechanisms or protections that you need to have in place to protect your data, right? So let's go through some of these questions here, and I want you guys to think about that as we go through the rest of the slides. So for example, what kind of authentication mechanisms can you use, right? Many customer organizations, they have certain requirements on they can only use SAML, for example, and they have their own identity providers and they want to use those providers. Or some organizations have requirements where they only want to give few users access to their clusters, and they want to use IAM roles, and then they map some of their users to these IAM roles. So you want to think about what's the posture that you want, what's the requirement that you need to meet. What are the data boundaries you need to create for your users? So, for example, you may have different application teams logging into the same OpenSearch service cluster. What kind of data boundaries are you looking for? What kind of data isolation requirements do you have? Do you need to isolate, indices and visualizations and dashboards in a way that when an application team logs in, they only see their data. They can only edit and read their own data. So you want to think about that. So you want to think about what are the different types of users that would be logging into this cluster. You may have security administrators, you may have DevOps engineers, you may have business analysts. They all have very different requirements on how they log into the cluster and what data they are able to access and query on. So you want to think about that use case. Do you plan on providing access to groups of users who have a common goal? So I gave an example earlier about different applications teams logging into the same cluster. You want to make sure that you have the proper security controls in place so that these team members can log in and only see the data that belongs to their team, right, or to their application, right? Yeah, so do you need to map multiple users to the same IAM role? So we had a customer in the banking sector who had a requirement of they have their own business logic outside of our service, where as the users come in, they have their own kind of authentication mechanism and policies, and based on those policies, then they would map those users to pre-configured IAM roles. This is also a common scenario that many of our customers like to use. They want to have more control over the access into the cluster. So Do you need to limit access to your PHI, PSI, or HIPAA data? Do you need to mask sensitive or confidential data? Do you need to audit some of that data? So if any of your users are accessing a sensitive field or a sensitive document, then you want to audit log that, and then you want to run analysis on top of that to see like who are the users trying to access this data and are they authorized. Then you can take some action on that. Do you need to encrypt your data? And the last thing you want to think about is what are your compliance needs? What are the different? All right, so let's jump in and talk more about these features. So there are really four pillars of security. For any security solution you're looking for, um, you should be thinking about these four pillars. So the first pillar of security is how do you protect your data and ensure that whenever your data is at rest, is stored in a disk, if it's in a swap file, if it's in a snapshot, or if it's moving between nodes, you want to make sure your data is always encrypted. And we have the AWS Key Management Service, the KMS that I talked about, where we store the keys that we can use for your data encryption. The next one is authentication. What mechanisms can you put in place to ensure that you have proper authenticated users accessing your system? Uh, we support many different mechanisms. AWS Identity and Access Management is a very popular one that customers use. The next one is the authorization, right? So once your users are authenticated, how do you configure the level of access for every user depending on certain user attributes? So if some users are, administrators, then what level of access do they need? If there are some business analysts, then what level of access do they need? There are many ways to configure authorization, but we'll talk about the different levers that we have within our service, but it's important to have an authorization strategy in place. And you can use find and access control within the OpenSearch service. We have multiple different authentication mechanisms and authorization mechanisms as part of that. And the last part is the auditing and compliance. So you have all the other three pillars set up, ready, but what happens when there's a security breach, or what happens when you need to investigate, how the data was accessed? What happens when a compliance auditor comes in and asks you questions on who has access to what and can you prove it? Do you have some logs in place? So those are some things that you want to think about, right? So these are like really the four pillars of security that no matter what system you're using, it's very important to keep in mind. And we will walk through some of the features that fall into these pillars and can enable you to protect your data. All right, so before we jump into security, let's just look at what a typical Amazon OpenSearch service deployment looks like. So on this slide, you can see that we have a customer domain here, in this box here. And within the domain, this one is using, it's a VPC domain, it's a virtual private cloud. And within the VPC, we have an application load balancer that is load balancing the requests that are coming into the cluster. We have some data nodes that are ingesting your data and processing the queries, as they come. We have ultra warm nodes. As many of you are familiar, we have multiple storage tiers. We have the hot storage tier, which is our data nodes where the data is being ingested, indexed, and queried. But then we also have lower cost, high performance storage tiers like the ultra warm storage tier, and then we also have a cold storage tier. And then we always recommend to have leader nodes that can help with a lot of that coordination. And you can see the domain also can talk to other AWS services such as Amazon CloudWatch or Amazon CloudTrail. So this is a typical deployment architecture, and yeah. So let's move on to security. So let's look at what's the 10,000 foot view of security, right? All right, so let's talk about OpenSearch security. It's really a defense in layers. So it's a multi-layer approach, and there are many different features that you can use to protect your data depending on your requirements, right? So if you look at this diagram here, you can see the we'll go from the outer ring to the inner ring. The outer ring are more broader security policies, and as we go further into the inner ring, you'll see how you can have much more tighter control on your data. So the outer ring here is the network policies. You can have IP, IAM, IP policies, other network policies to just control the traffic that's coming in to your cluster. And then you have the virtual private cloud. It's really like a data center network that you would have on-prem, but this is in the cloud. It is your own private network in the cloud and at scale, right? So you can keep all your data, all the requests, and kind of secure your data in that way. The third level is the authentication and authorization, which is where IAM comes into the picture. Um, so the identity and access management allows you to create policies to control what principals have access to what data, what resources, what actions they can take on that data, right? So you can create some of these policies for your OpenSearch service cluster. The next we have is the encryption at rest and in transit. We talked about this a little bit, and you can use AWS KMS keys. Either you can use the ones that we will create on your behalf and store it in your account, or you can bring your own key. And the inner circle is the fine grained access control. This is where you can have a very deep granular access and data permissions control. So you can decide if your users have the ability to access certain indices or certain documents. You can even further be granular by saying my users can only access certain fields, or even you can mask sensitive data from certain users. So it has a lot of different controls, and we'll talk about some of those controls. But the takeaway on this slide is to think about security as a defense in layers, right? So many customers ask this question: is this is great? There's a lot of different security features and controls with Amazon OpenSearch Service, but where do I really start, right? And this really goes back to our previous slide, or our earlier slide, where I was posing, list of questions to you, is to really think about what are the security needs of your organization, right? You don't have to enable all features. You can pick and choose whatever features are important for your organization to protect your business data. So what I've done here is I've just put some of these features in three buckets, right? This is purely just a guidance, and there's no such fixed buckets. You can mix and match features as needed uh, for your organization. So if we look at the leftmost bucket here, which is the minimal security, you'll see that there are some features in there such as an IAM IP policy. So at the very minimal, you want to have an IAM IP policy to protect your domain, right? Because if you leave your domain open, then it is vulnerable to attacks and anyone can access it. So at the very minimum, you want to have an IAM IP policy that says only these subnets or these subsets of IPs can access this domain. Then you want to have a domain endpoint security. So you want to enable HTTPS on your domain. We support TLS 1.0, 1.1, and 1.2. So you definitely want to. You can also pick which TLS version you want, but we recommend that. Then you want to at least enable encryption at rest, so your data is always protected where it lives. If it's on a disk, if it's in a snapshot, your indices, your swap files, and many other data sets are protected at all times. Then we have the so you can choose to just have the AWS managed key, so you don't have to worry about creating a key. We will do that for you. Also, one thing you want to make sure is when you're sending API requests into your cluster, then they are SIG-v4 signed. This is a mechanism that allows you to use the AWS generated credentials to sign these requests that are coming into your cluster. So you're always sure that the requests are authenticated and using the right set of credentials. And then AWS CloudTrail logging. So any configuration changes on your domain, anyone tries to create a domain, delete a domain, update a domain, make some security changes on the domain, all of those things are logged in AWS CloudTrail by default, right? So this is, we enable this for you. So we want to make sure that you have at least a minimal security posture, with the least friction. So that's your minimal bucket. And then moving on to the right, or to the middle bucket, which is your basic bucket. um, Certainly, you want to enable everything we talked about in minimal, but in addition, we highly recommend that you enable virtual private cloud on your domain. You can also then add security groups and other VPC configuration that further limit on what type of traffic can come into the VPC, what type of traffic can leave the VPC. So this is very a tight controlled security mechanism, and we highly recommend that you have VPC enabled on your domains. We also recommend that you have encryption in transit in addition to the encryption at rest we talked about. There are two more policies now you can use with your VPC domains. So there's an IAM identity policy and IAM resource policy. So the identity policies can help you specify what principals can access a service, right? So they are oriented around a principal and what they can access, what actions they can take. And then there are IAM resource policies, also known as domain access policies within Amazon OpenSearch Service. The resource policies specify which actions a principal can perform on the domain's sub-resources. So you can control this further down to a sub-resource level. Within the domain, you may want your principals to only access certain indices, or you may want your principals to only have certain actions on certain sub-resources. So you can control that down to the sub-resources. And the last one is you could use AWS managed keys, but we also recommend that you bring your own keys if your organization needs to protect the data with your own key. You can go ahead and create an KMS key, and then once you're creating the domain, we will have the option where you can say, I want to provide my own key, and then you can provide your own key. Okay. Um, right. And then we have the advanced one where we'll talk about the fine-grained access control and how you can have much more granular access on your data sets. We also have the SAML, Cognito, OIDC. So if you have other authentication mechanisms that you would like to use, then we recommend that you enable fine-grained access control. We talked about audit logging and compliance. This is another area that we recommend you enable if your organization needs are to make sure have all the auditing logs. We will talk about document and field level security, where you can control at a much granular level what access and what permissions to the data that you're providing to your users. We also have dashboard tenants. Dashboard tenants essentially allow you to um, create isolated spaces where different application teams using the same cluster can only have their customized view of their data sets and their visualizations. And then we also have a custom domain endpoint where you can, instead of using the default endpoint, you can bring your own custom endpoint. In your organization, you can just say abc.com, slash dashboards, and you can bring your own certificate to configure those endpoints. So it's just a little more secure. So these are different features that we have. You can mix and match them as you need. So we talked about some of these controls in the previous slide. The thing to keep in mind is some of these security controls are outside of the cluster, right? So even before your request gets to the cluster, we give you these security mechanisms to make sure that you only authenticated users with the right permissions, right identities are able to access the cluster. So we talked about the IAM IP-based policy where, if you're not using a VPC at a minimum, you want to make sure that you can control which subnets can access your clusters. Although you don't have like any audit logging on your requests, but at least you can control which IPs are allowed into your cluster. We talked about VPCs. You can use security groups within VPCs. Security groups work at an instance level with allow rules. Um, NACL is the network access control list. They really act as a firewall. It's similar to security groups, just a firewall for your VPC. But NACLs act at a subnet level, and they have much more controls over the allow and deny traffic. And then you can also use VPC flow logs for auditing your network traffic. So as your logs as the requests are coming into your cluster, you want to create maybe a dashboard of what IPs are sending the most traffic or what IP addresses are sending the most requests. So you can use flow logs to further dive deep into your network traffic patterns. And the last one we talked about is the IAM identity policies, which will help you. I think there's one more. Yeah, so identity and the resource policies, which will help you to have much more granular control over how the requests are authenticated and sent to your cluster. So keep in mind, all these security controls are outside of the cluster. Right now, we'll talk about some security controls available inside the cluster as part of the Amazon OpenSearch service. So I want to share with you guys some concepts here that are very important to understand before you can use the features available with the service, right? So we have something called users. Users are just principals who make requests to your OpenSearch clusters. But the important thing is every user is authenticated and they have credentials. So then we have permissions where you can assign individual permissions or a group of permissions to your users, such as who can create an index, who can delete an index, and so on. Then we have roles, right? So you may have many different types of permissions, but roles essentially help you to scope a set of permissions. You can add a different types of permissions into a role, whether it's a cluster level permission, whether it's an index level permission, or a document or a field level permission. Everything can be defined in a role, and then it just helps you have like a clear view of what that role is able to do on your cluster. Then we have a concept of backend roles, which are nothing but external identities. So if you have users logging in from your SAML IDP or through other authentication mechanisms, you need to be able to map those external users based on some user attributes into the cluster. So for example, so you may have backend roles for a user who's an administrator, right? Now, administrator may belong to multiple groups. So those are like user attributes. When an administrator logs into the cluster, we can look at the attributes of the groups that the administrator belongs to. And based on that information, we can map the administrator to already predefined role in that cluster, right? And that's exactly what role mapping does, is where you can users can assume roles once they've authenticated and once we match the backend role to the predefined roles on the cluster. Dashboard tenants, essentially it allows you like sharing of data and visualizations between common groups of users or roles, right? So it helps you with your data isolation needs. Okay, so let's talk about security controls available inside the cluster, right? So far we've gone through, I think, three of those layers that we talked about. We saw this graphic of five layers of security. We've gone through the three layers already, and now we are further deeper with the fine-grained access control. If you remember, this was an advanced security capability. Um, Not everyone may desire to use this, but we highly recommend this because this gives you a lot more control and access to how your users interact with the data on the cluster. So let's talk about some of the aspects of fine-grained access control. The first one is identity management. So fine-grained access control allows you many different approaches to manage your identities. You may choose to have local identities on the cluster. So maybe you only have a few users who are logging into your cluster, and you don't really want to go through configuring complex authentication mechanisms, but maybe you already have the IAM policies in place, and now you only need to give some users access to your cluster. You can have the basic authentication where you can have local users. It's like a local user database on your cluster, right? You can define these users and add them in the cluster itself, and give them the access. We also support SAML, so you can have existing identity providers where you don't want to redefine all the authentication mechanisms and redefine and bring over all the users to a new system. You can just use your existing SAML provider. So if you're using an Okta or a Ping or somebody else, you can use that and just authenticate into the system. Right? You can use Cognito also if you have a requirement. As I was mentioning earlier, some customers want to map a group of users to an IAM role, and then they use that IAM role to then log into the cluster. So Cognito has this concept of user pools. You can configure those and use also Cognito. Also, Cognito supports OIDC. So if that's something that your organization uses or needs, then you can use Cognito. Of course, we support IAM users or principals. And many customers ask us, "Hey, we already have an Active Directory server. How do we kind of integrate with the Amazon OpenSearch service?" So, as I said, we are SAML compliant, SAML 2.0 compliant. If you can use an ADFS server, right, the Active Directory Federation service, that sits between your Active Directory and our service, and that can do the translation for you. So you can connect it to your Active Directory if you have that in your organization, but you do have to go through a few extra steps to configure the ADFS. So we talked about cluster and index permissions. So cluster permissions are things like monitoring the cluster, monitoring the health of the cluster, or seeing what are the tasks that are queued up in the cluster. So very high level, cluster level permissions. And then there are index level permissions, which are more granular on writing to a specific index, or having the ability to delete certain indices, right? So next we have the document and field level security. This allows you to have much more granular access over the data sets. You can choose a regex pattern and then say if the document matches this pattern. So for example, if the document contains a field title equal to a certain key value pair, only then allow this user to be able to see this document. Or for example, if the document contains the logged in user's username, only then can the user see the document, right? So we have much more granular controls at a document level as well as a field level on what the user can see. Next, we have a field masking. So you may want to limit the access to your data, but in addition, you may also want to mask certain data. So for example, if you have you shouldn't be putting social security numbers in your logs, but I'm just going to take that as an example. So if you have like SSN numbers or email addresses in your logs, and you want to mask that because you don't want anybody to be able to like look at those email addresses, it's customer confidential data, but you still want to be able to aggregate over that at a high level, like how many email addresses you have. So you can mask that data. You can provide we talked about audit logs. Essentially, we have two types of audit logs. We have audit logs that we send to CloudTrail. These audit logs essentially are um, any updates, activities on the domain itself. So if when someone creates a domain, when the domain is deleted, if there are any configuration changes, all of those changes are automatically logged to CloudTrail. And then we also have audit logs for ES APIs, right? So if your users are sending API requests um, to your cluster, then all of those APIs will be logged. We'll talk more about this. And then we have dashboards, multi-tenancy. So I want to give you guys an example of some of the permissions. So the cluster level security can have permissions such as who has the permission to take a snapshot, right? So these permissions operate at a cluster level. So they're not granular to specific indices or index patterns. It's really for the cluster. Who can monitor the cluster health, for example? That's another cluster level permission. Then we have index level security where we can define permissions for specific indices or index patterns. So for example, who has the permission to write to certain indices? Remember, you can define specific indices, and you can also have like a regex pattern. So you can say production star or 2020 star. So those indices and can be like a pattern, and then you can define permissions for those indices. So in this case, if I said index level permission is production star, like now my read permission here, indices data read, will be only on those specific set of indices. Similarly, permission to write, and there are many other index level permission, but this just is just an example. And then we also have plugin level security. So you guys may be aware of alerting, anomaly detection, and many other plugins that we have with Amazon OpenSearch Service. You can control the permissions at the plugin level. And every plugin has granular permissions. So for example, you may have a reporting plugin and you want to have permissions on who can create reports, who can share reports, and so on and so forth. Or you may have permissions on who can manage the data life cycle of these indices, who can move the indices, from hot to ultra warm. So you can define those ISM policies, but you won't only have specific subsets of people who can do these actions. So plugin level permissions allow you to define those permissions. And these are just some examples here that we talked about. We talked about the document level security, where you can match a certain field or substitute parameters in a document. We talked about field level security where you can actually include or exclude fields. So for example, in a field level security, you can say for this index, I only want the user to be able to see these four fields, right? So any other fields will be excluded. So that's your include aspect. And then we have an exclude aspect where you can say, these are four fields that I do not want any user to see, and everything else is okay. So we have much more granular access with the field level security, and that can kind of help you accomplish your desired security posture there. And field masking, I just wanted to give an example here. So if you look on the right side, we have these fields inside a document, but the third field here is masked. So users cannot really see what the value of that field is, but they can aggregate on that field. Right? So the role mapping workflow has all the permissions in one place, right? Um, if just to quickly refresh, the role mapping allows you to combine all sets of permissions. We talked about index level permissions, cluster level permissions, document and field level security, and tenants, right? But how do we combine all of that in a simplified workflow that is easy to understand so that when you look at this role, you right away know these are the different permissions of this role. So if you have to assign users or other external identities to this role, it's very clear to you what those roles, what the capabilities of that role are. And the role mapping workflow allows you to define all of these permissions in the same workflow. Okay. So this is an example of an auditing domain configuration management update. We send these updates to CloudTrail. You can also further create a trail to write these CloudTrail events or data to S3, because you may want to further analyze and create dashboards or insights from this data, or archive it for your business needs. So we support all of these actions. This is just an example of an update domain config. There are other events that are supported, such as any changes on the domain, any modifications of parameters, any new domains that are being created. So everything is logged. This is an example of an OpenSearch request that is being audit logged. So any request to the ES APIs, Elasticsearch APIs, are audit logged. You can we have some controls on what level of audit logging that you desire, but some of the common categories that we log are if there is a failed login, right? So there are bad credentials, then we're going to log that, which IP address, who was trying to provide these credentials. So there's some information there. If there is spoofing, then those requests are logged. Or if there are invalid certificates, right? If somebody is presenting an invalid certificate, then we can audit log those as well. If a request has missing privileges, so the user is authenticated, but they're trying to access, data sets, or they're trying to execute permissions on data that they don't have access to. So they're authenticated, but they don't have the privileges. We also audit log those users. And even valid requests that are coming into the cluster can be audit logged, because maybe you want to do further analysis on uh, who are the most common users sending requests to this cluster, what type of requests are they sending. We also log the request itself, and there are some controls and that you can choose there, but you can see exactly the query that came in to the cluster, and you can do further analysis. And we have had a customer who was running into an issue where they noticed that certain requests were like taking up more CPU cycles, or were slowing down the other users because there's like heavy load on the cluster. They really wanted to analyze what was going on. So they looked at our audit log requests, and as I mentioned earlier, we forward all of these to Amazon CloudWatch logs, and they did further analysis on them that helped them to understand how some requests were coming more commonly from a specific IP address or a user, and how they could control that to further balance the load on the cluster. So it can be very useful. There's a lot of data in these audit logs. Um, Audit logs also support an advanced level of configuration, where you mean for your compliance purposes, you may need to watch on a specific index. So let's say that you have a lot of data on your cluster, but then you have specific indices that have some confidential data in it, and you want to watch those indices. So any user at any time making any request to that index will be automatically audit logged, right? Be careful when you configure these compliance related configuration, because it will take up additional CPU cycles, because every request coming in will be checked whether it's trying to write to a specific index. So that's one. You can also watch on specific fields within the index. So you may say, like, that's fine if people are accessing this index, but within the index I have some fields, such as email addresses or SSNs, or some other confidential data, that you want to make sure if anytime anybody tries to read that data also, it will automatically be audit logged, right? This could be a very critical information for you in times of like a security breach where you're trying to understand who had access to this data, who looked at this confidential data at what time, where did the request come from, and a lot more details, right? So there's something to kind of keep in mind for your for security use cases as well. You can also monitor writes to a specific index. Anytime data is being written to that index, it will be automatically audit logged, again with all the details of the user, the request, etc. And then you can also ignore users. So you know that there's, this administrator obviously has access to all of the data, and I don't want to keep logging every time the administrator touches this index, because that's his job to look at this index. So you can say, all right, let's ignore these users. So only you're not seeing a lot of noise basically. So we have those controls as well. So those are the compliance configurations that are available as part of the audit logging capabilities. The one more thing I want to cover here is encryption at rest. We use AWS Key Management Service to store and manage the keys. Every data node can interact with AWS KMS. It's an AES 256 key, so it's a very high level of encryption. You can bring your own key if that's what you prefer. We do support that as well. And here are some items that we encrypt along with using this key basically. So we derive data keys from the KMS key. We encrypt your indices. We encrypt any OpenSearch logs, any swap files, any automated snapshots, and any other data in the application directory. Everything is encrypted. All right, so we've been through some of the security capabilities that are available with Amazon OpenSearch Service. We've talked about um, security capabilities that are available outside the cluster and then inside the cluster. I wanted to leave you guys with some security best practices. So don't give broad access to your domains. This is very important. Please at least enable the minimal set of security features. We highly recommend that you create your domain in a VPC and use security groups, so you have much more tighter control over what traffic flows into your subnets. Use a combination of IAM identity policies and resource policies. Please use fine-grained access control with the open domain access policy. So if you're using fine-grained access control, then you don't have to put all the granular controls in IAM, because IAM, as I said earlier, is outside the domain, and fine-grained access control is inside the domain. So you have much more granular access. We have had customers who did not have fine-grained access control before, and they've already have been using their domains for some time. And now we've recently also added support earlier this year on enabling find and access control even on your existing domains. So we have enabled that. So please use find and access control. Enable encryption of data at rest as well as in transit. Again, this is also supported on existing domains. If previously you did not have this, you can go ahead and enable these features on your existing domains. Also enable secure communication with SSL TLS, so HTTPS is mandatory. We highly recommend that. We also have some slow logs and error logs and audit logs that we send to CloudWatch, as we talked about earlier. You keep in mind that once the data leaves the OpenSearch cluster, then it falls into the shared responsibility model, where if now the data is in CloudWatch, then it is your responsibility to encrypt that data if that is needed for your organization. So we recommend you do that too. And monitor CloudTrail for all user activity on your domain. Enable audit logging if needed. You can also enable the compliance configuration parameters. And just a few notes here. We're also we've added some enhancement on our domains that will not allow you to create public access domains anymore. We want to make sure that we protect our customers and their data. Okay. All right. So in summary, we've talked about several aspects and controls that security controls that you have with Amazon OpenSearch Service. We talked about using virtual private cloud. We talked about using IAM integration to control how IAM principals interact with your OpenSearch service clusters. We talked about find and access control if you desire to have much more granular access over indices, documents, fields, your plugins, for example. So you can use find and access control. Encryption is highly recommended. Auditing of data may be needed for your compliance needs. So we support that. And we also integrate with third-party identity providers like SAML and Okta, uh, Ping identity, etc. So just wanted to highlight here that we have customers across multiple domains who are using our service. If you look at the software and internet vertical, we have, Adobe and Autodesk. For media and entertainment, we have Netflix, Fox News. So these customers are using our service and taking advantage of many of the features that are available as part of our service. So I'd highly recommend that you give it a try and try out the security features. So how do you get started? Well, it's easy. You can launch an Amazon OpenSearch service in a matter of minutes. We have a getting started tutorial that will help you quickly ingest data and index data and run queries. And then we have a dedicated page for security that can help you navigate all the different security features that we have with our Amazon OpenSearch service. Um, these are just some resources on the slide. Feel free to use those. And thank you all for coming to this webinar. This is much appreciated, and we hope that you found this useful. Thank you.